All right, let's continue our discussion of trig derivatives. So in the previous couple videos, we talked about where the derivatives of sine, cosine came from. Then we used that to show how to prove the derivatives of tangent, and we had cosecant, and then I left it as an exercise to you to do the rest, the other two last functions. So now let's use those in conjunction with the previous properties that we have discussed about derivatives, like the product rule, quotient rule, constant multiple rule, etc., etc. So these are, from here on out, our derivatives are going to get more and more interesting. Maybe you might think that means more and more complicated, but as long as we're applying the properties correctly, it's just a matter of following the correct steps. Okay, you just got to make sure to remember your quotient rule, your product rule, your constant multiple rule, all that kind of stuff. Okay. Now, when I have a here, f of x equals x sine x plus 2 cosine x, the first thing I see is I have the sum of two functions, x sine x plus 2 cosine x. So to me, that screams, okay, I can differentiate those individually according to the sum difference rule. The next thing I see is that, hey, there is a product of two functions. There's x times sine x. That's going to require the product rule. And then I also have 2 times cosine x. Now, you might think to yourself, well, okay, that is the product of two functions. Yes, you're right. 2 is a constant function times cosine x. But you don't have to use the product rule for that second term because 2 is a constant. We can apply the constant multiple rule. So here, let me show you all the steps here. How I would do this would be f prime of x equals, okay, first I'm going to differentiate the terms individually. So x times sine x plus the derivative with respect to x of 2 cosine x. Okay? And now this first derivative is going to require the product rule. And the second one, we can apply the constant multiple rule to basically factor the 2 out of the derivative. So let's first apply the product rule. The product rule says you take the derivative of the first function, x, times the plane second function, plus the derivative of that second function with respect to x, times the plane first function. Okay, so that's just the product rule for this first derivative. And now we have to apply the constant multiple rule for this second derivative. And we get 2 times the derivative of the variable part, which is cosine x. Okay, so now we can go ahead and evaluate each of those derivatives and then collect any like terms that we need to, and we're on our way. So what's the derivative of x? 1. So 1 times sine x. What's the derivative of sine x? It's cosine x. Cosine x. Now be careful here because, okay, that's probably not super clear notation on my part. Cosine x times x. What you don't want to say is somehow, combine those two x's and say it's cosine x squared, because it's cosine x times x, two separate functions multiplied together. That other x can't somehow wind up inside the argument of the trig function. So I put parentheses around cosine. On the next step, maybe I'll put the x in front just so there's no confusion at all. Okay, plus 2 times the derivative of cosine, which is negative sine. Now, a common mistake I see with students is to do this. Whenever you're differentiating like a situation like this, I'll say students I'll see them that will correctly say the derivative of cosine is negative sine, but they'll do this. And they'll end up doing 2 minus sine. But it's not 2 minus sine, it's 2 times negative sine. So be careful when you have that situation. Okay? It is 2 times the derivative of cosine, which is negative sine. So use parentheses there, it'd probably be a good idea. Okay, so let's clean this up a little bit. We have 1 times sine, otherwise known as just sine, plus, I'm going to put that x in front of the cosine just so there's no confusion. X cosine x. And then here we have 2 times negative sine, so that's negative 2 sine x. And now if we want to collect like terms, we have a positive sine and we have negative 2 sine, so that's negative sine x plus x cosine x. Okay, cool. Easy peasy as long as you follow the rules. All right, what about example B here? Example B. So we have g prime of x is what? Okay, I'm looking here at B. What do I see? First thing I see is a quotient. Quotient's the first thing I see. Is there a way to rewrite that to where it's not a quotient? Technically yes, but we're not there yet. So we're stuck with the quotient rule. Okay, so what does that mean? Well, of course it means we have to apply the quotient rule. So let's see here. Let's just get our big vinculum here, the big fraction bar. Now, if you want, you can go ahead and say that, well, the bottom is going to be the bottom function squared, so 1 plus tan x squared. Okay. Now, the numerator is going to be the derivative with respect to x of the top, so 1 minus tan x, times the bottom function, 1 plus tan x, minus the derivative of the bottom function, 1 plus tan x, times the plane top function, 1 minus tan x. Okay, let's now take those individual derivatives. What's the derivative of 1 minus tan x? So the derivative of 1 is 0. The derivative of tangent is secant squared, but the derivative of negative tangent would be negative secant squared. So negative secant squared x times that 1 plus tan x. Okay? Minus, what's the derivative of 1 plus tan x? Well, okay, the derivative of 1 is 0. The derivative of tan x is secant squared. Secant squared x times that existing 1 minus tan x over the denominator, 1 plus tan x quantity squared. Now, I'm looking at this, and we need to simplify as much as possible. You always need to simplify as much as possible. I am seeing that both terms on the numerator have a secant squared in them. In fact, they both have a negative secant squared. So my first inclination would be to factor out a negative secant squared and then see if we can get anything to collect like terms or simplify or something like that. So let's just see what we can do. Let's see here. If we factor out a negative secant squared, what would be left over would be 1 plus tan x, right there. And if we factor out a negative secant squared on the second group of terms, we would have, we're factoring out the negative, so we'll be left with just 1 minus tan x. So plus 1 minus tan x, I think. Okay? Yeah, so 1 plus tan x, and then we would factor out the negative secant squared, we get 1 minus tan x. Of course, over 1 plus tan x squared. And what do we have here? Okay, so negative secant squared. We have 1 plus 1 is 2. Then we have positive tan x minus tan x. So those add to 0. So I guess we have 2. Okay, so I can actually make this a little smaller then. Since we just have 2, that set of parentheses just simplifies to a 2. So then 2 times negative secant squared, so negative 2 secant squared over 1 plus tan x squared. Okay, 1 plus tan x squared. Can we go any further than that? Now, of course, with trig, you can always run around in circles. And so you always have to ask yourself, is this the best I can do? Because, of course, secant squared, we can use a Pythagorean identity to rewrite that. Is it better? I don't think so here. I think that is as simple as we're going to get that. I could be wrong, and it's easy to be wrong with a trig function, but I think that's good. I mean, the denominator is 1 plus tan x quantity squared. Of course, we could multiply that out, but that's not going to help us, I don't think. Oh wait. Oh wait. Wait a second here. Secant squared. Oh no. No. Okay, I was thinking. I was thinking 1 plus tan squared x, not 1 plus tan x quantity squared. Because there is we could have. Okay, never mind. I think we're good here. I'm gonna stop. Okay, I think we're good on the simplifying that one. Okay, now what about C? All right, let's see here. So C. Okay, and the first thing I see here is that we have a quotient, so we're going to apply the quotient rule, of course. I don't really see anything else special, so let's just apply the quotient rule. And we have, let's see here, so that's h prime. Quotient rule says derivative of the top function 1 minus sine x times the plane bottom function cosine x minus the derivative with respect to x of the bottom function cosine x times the plane top function 1 minus sine x over cosine squared x, the bottom function. Yeah, I'll write it. I like to do that to start with. Cosine x squared. Okay. So what do we get when we actually differentiate those individual terms? The derivative. Okay, we're technically applying the sum difference rule, right here. The derivative of 1 is 0. The derivative of sine. Technically, that's a constant multiple rule because we're factoring out a negative 1. Then the derivative of sine is cosine, but there's a negative out front. So that derivative is just negative cosine x times that existing cosine x minus, okay, what's the derivative of cosine? The derivative of cosine, remember, is negative sine. So negative sine x. So it's like don't forget there's a negative sign built into the quotient rule, but then the derivative of cosine is also negative. So you get a double negative there. So it's negative sine x times that existing 1 minus sine x over the denominator cosine squared. Okay. Now we have some cleaning up to do. We have negative cosine times cosine. Of course, that's negative cosine squared x. We have negative, that's a positive sign. But sine, and we're going to distribute, so it's positive sine times 1. So plus sine x. And then we have, what? We have positive sine times negative sine, so minus sine squared x. Okay, let's double check that. We have negative cosine times positive cosine, that's negative cosine squared. Then we have a double negative sine, that's positive sine times 1, so it's a sine. Then positive sine times negative sine squared. Of course, over now, I'll go ahead and write that as cosine squared x. Okay. Let's see. So I do see that we have a cosine squared, or a negative cosine squared, and a positive cosine, another negative sine squared x. Let's group those together. Then I think we can apply the Pythagorean identity like we did relatively recently. Remember that sine squared plus cosine squared. Oh, I forgot x's equals 1. Okay, that's your basic Pythagorean. Now we don't quite have that, but I think we can achieve that by grouping negative, sine squared x minus cosine squared x, grouping those squared terms together, like so. And then next, factor out a negative sign. If we factor out a negative sign from that grouping, we'll have negative 1, and we'll have sine squared x plus cosine squared x plus that sine x over cosine squared x. And what can you do? Well, sine squared plus cosine is 1. So we can replace that parenthetical expression with 1. So in other words, 1 times negative 1 on the numerator, you just get negative 1 plus sine x over cosine squared x. Okay. Can we go any further? I think we're good. Let's see, cosine squared. Can we do anything with that? Cosine squared. Yeah, well, let's think about this. Let's see, cosine squared, using our Pythagorean over here, we could say cosine squared x is 1 minus sine squared x. I suppose we could say that is equal to 1 minus sine x times 1 plus sine x. Does that help us? No, because we have on the numerator, we have sine x minus 1 instead of, oh, but we could factor out a negative sign. Interesting. Did I mean to do this? I don't know. Let's see. Okay, so look, see what we're doing over here. So we take our Pythagorean here, identity. If we subtract sine x from both sides, okay, that's easy enough. But notice that the right-hand side is now the difference two squares, 1 squared minus sine squared. So we could factor that as difference two squares, 1 minus sine, 1 plus sine. Okay, so I can now replace the denominator here. In fact, I'm going to do 2 steps. What if I factor out a negative sign from the numerator? If I factor out a negative sign, that would be a positive 1 minus sine x, like so. I factor out a negative sign. Now, if I replace the denominator with what I have shown it is to be equivalent to right there, well, I could write as 1 minus sine x, 1 plus sine x. And now there's that nice cancellation. 1 minus sine x, 1 minus sine x. So we get negative 1 over 1 plus sine x. Interesting. Cool. It's been a while since I've written this, so I didn't remember that happening. But that's cool that we have that nice simplification. There we are. So there is our simplified. I don't think there's any way you can get any more simple than that. Of course, with trig, you can always rewrite it, but I think that's a nice simplified version. Okay. All right, so there's examples of trig functions using product rule, quotient rule, constant multiple rule, sum difference rule, trig function derivatives in conjunction with a lot of other derivative rules you talked about. So practice, 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 practice is key here. So just make sure you're practicing a lot. And if you need to refresh on your trig identities, especially the Pythagorean, maybe a double angle, sum difference, those come in handy, but especially your Pythagorean and your basic ones, just make sure to do that if you need to refresh those. Okay, as always, don't hesitate to reach out if you have questions. I'll catch you in the next video.